All right, today is our ape study day, so we're going to talk about any ape-related topics that people would like some last-minute cramming on. So something already in the queue, people know what that means now. Is talking about a dummy head versus a non-dummy head. So we know that a linked list is really just a structure that has some fields, a head and a tail. That's basically it, right? We have pointers to these node structures that are head and tail. And when we construct this object, they start out null because the list is empty. So these aren't pointing to anything in our heap memory. These are both in our stack memory. But if we have the concept of a dummy head, then the head is always initialized. So I'm going to use a singly linked list. So we're going to call this the head, and this points there. This will have no data in it ever, and start with an empty pointer. So this is just something that is always going to stick around. The real head of the list is going to be if this points to anything. But you can always query, and if the list is empty, then it has a pointer. If it doesn't have a pointer here, this head.next is null, and that tells you that the list is empty. But you always have this node here. We call it a dummy head.
So even a list of size 0 would still have a dummy head
It would still have a dummy.
if the dummy doesn't represent size.
Yeah. So the real head is going to be the next thing. It's going to point to the next list. Like the actual list would start down here, and you would have. This is the first real value down here. That's really, if you want to return the head, then you would start immediately from that. I honestly don't know why people implemented it that way. It's never made sense to me.
Do you think dummy heads are better than non-dummy heads, or do you think they're worse?
I think they're worse. I don't think it's completely unnecessary. It's memory that we don't really need. It complicates things like a circularly linked list, so you have to worry about where the dummy head is. Or you have the tail cycle back around here. And then we have 2 pointers to that first node. And either one, just to me, is a little weird. It's way easier to just check if the head field is null, rather than having the head always exist and check whether it's data or check whether its next is null. It's weird to me. But it's something you need to know. What do we do? What do people feel weak at or want some additional explanation for? Yeah. So the cut list said we're giving an index and we're gonna split the list into 2. Are we returning, so this was on your first exam. Are we returning the first, I made up the return value on the exam, but I didn't get that directly out of the 8. What is it having you return? The list that we're removing from the list. So the first part is still this object, and the second half is exactly what I put on the exam. That intuition is not legal. So we have some kind of list. Do we want to do this? I guess everything in the is singly linked, right? So we're gonna do this with a singly linked list. We're gonna call cut into 2, or cut, I guess cut list. What index do we want to pass? And according to your documentation. Do you cut before 3 or after 3?
You'll cut. Yeah, you'll cut, so two like documents or whatever would be, no, yeah, like that.
Alright, so we're gonna cut, we want the list. The new list that we return to be, or for this object to be 3, the list we return to be of size 2. Yeah, let's do that. So we know we have a structure that has a head and a tail pointing to those 2 nodes. Somebody walk me through this. How do we start?
You'll need to make, the node for your current, your previous, and then you'll need to make another linked list. And you'll need an eye.
So we probably need something like. If we're not using the method that we had before, like find node before, I'm guessing that does not exist for this. So in that case, we need some kind of if statement that's going to check whether the size is 1 or less. If the size is 1 or less, that's gonna change our logic for this, because we wanna start current here, we wanna start previous here, so that we can walk them up together. If we start, if the list is only of size 1 and we try to access head.next, we're gonna get a null pointer exception. So. I guess we're gonna look at the. There's gonna be separate logic for a size is less than or equal to 1. Inside of this, then we just need to look at cut list, because this can either be 0 or 1. I guess we'll first say if size is 0. Throw some kind of exception. I guess we're gonna call this. What's our node structure? We're not doing this generically, right? These are always integers. So kind of
It'll be strings. So. But I mean, they tell us what we have to do for the param checking.
yeah, so whatever this type happens to be. Node of that type.
Okay, it just said no.
Yeah, they just use the object types. We were given one add first method.
Does this make sense to people? So if the size is 1, then we need to figure out, we're not gonna have our general current and previous setup, because there's only 1 node to look at. So we need to figure out if this cut value is at 0, saying to return this node. or if the cut value is 1, which says make no changes. So we have those two cases to worry about. So here, if cut is 1, we just return the head. Because we don't need to make any change, we're returning this value as the. I think that makes sense, right? If we wanna cut here, I guess we wanna return nothing, we wanna return null, and the list stays the same. I think this makes more sense. Otherwise, we wanna return this temporary node that used to be the tail. So head and tail would both point to the same node. If cut is 0, there's only one node, which says that we want to make this list null and return this node. So we would set head to null and tail to null, it says that this object's head and tail don't exist anymore. This list is now null and empty. We store off this value that used to be here, and then we return it as the head of the other list. Once we go through all of this logic, I think we are good, solid, to assume that we have a current and a previous. So we'll get through all of this. And there are returns everywhere. But we can still throw it in else if we want to. Else, we're going to say. So we know the size is at least 2 to get here. We want to set prev starting out here as the head. And we want cur to be the node after the head. Now we want to iterate until cur is pointing at some counting variable that represents the value of this. So we want to do a loop 3 times. I guess in this case it's 2 times. 1, 2. So we want to do something this minus 1 times. So if cut is 3, we want to do something twice. So we want from 0 up to cut minus 1. That gives you 0, 1, stopping at 2. That's the 2 times we want. And it will scale with the size or value of cut. So that many times we want to bump up both current and previous. Move those forward to their next node in the list. So by the time we're done with this, our values of prev and cur should be here. Where do we go from here? We want to make this cut in between prev and cur. We could, but then I guess we do still technically have access to cur. So we're gonna want to do that eventually. But I think we want to call a linked list constructor first. We want to basically make a new, so right now we have a list that is this object. I'm just gonna label this as this. That has a head pointed here and a tail pointed here. We want to make a new list. with a head pointed here and a tail pointed here. So we could say something like. What does the linked list constructor take?
Default constructor that takes no params, otherwise you have object data and the next. That is enough.
That would make sense if you have a dummy head, right, I guess. So we're gonna assume we have no dummy head, since this doesn't have a dummy head. So we then need to set the head and the tail, and I'm guessing for some reason they are publicly accessible. Is there a get head and set head, or are they publicly declared?
And they're just publicly declared.
Discussed.
There's no tail, and there's no get head stuff. There's just an add first built in like that, where you're setting that. And that takes the node constructor with data and the next pointer to this.
So we would say something like. So this is not encapsulated at all, good to know. New list dot head equals current. We want the head of the new list to be what current is currently pointing at. We want new list dot tail. To point at this current tail. This dot tail. And now we have code that matches our current image. But there are still some things we want to do. What do we want to do?
Have to adjust the size.
We definitely have to adjust the size.
That previous as the tail for the first one.
Sorry.
We need to set the previous as the tail.
Yeah, we could definitely modify this dot tail now that we've used it in a way that we need it. We can set this dot tail equals pre. And that will move this arrow. Taking a sharp detour here to that node. Now we have our two lists. So now we have to modify the size. What is the size of the first list?
Whatever the comes.
Yeah, the parameter that we passed here, so cut. So we could say, this is probably gonna fall off the board for those of you who are remote. I will draw this now, this goes over there. We have this dot size equals cut. But we want to do something before we do that. We want to set the size of the new list. If we set this dot size to cut, how do we know the size of this? We have to iterate. We don't want to write a loop unless we have to. So we could say new list dot size. And what is the size of the new list?
Old size minus the cut.
Yeah, this dot size minus cut. Does that make sense? The old size was 5, 5 minus 3 is 2, which is the size of the new list.
No, there's no tail on this example,
Oh no, we don't have a tail.
which is not great.
That makes things a little bit harder. Means we need another loop or two to figure out where the tail is. So we can modify that wherever we're accessing tails. So if there's no tail, we don't need to worry about this. Here, you're allowed to write helper functions?
It depends. I'm pretty sure they'll like specify if you can, if you can.
So if you're not allowed to have a tail, then we need something that starts somewhere and goes until the current dot next is null, and that node is going to be the tail. So you would just have a node temp equals head. Actually, we're gonna call this tail. And then inside of this, we're gonna have while tail dot next is not null, then tail equals tail dot next. There, we found the tail. Now we have a tail pointer. For the rest of this, we can just use tail. Is that, does it specifies that we need to change the parameter? Is that what it's talking about? And set it to size?
Yeah, if it's less than 0, then you change the index pass to 0, and then you just cut at the beginning. And then if you give a number larger than the size for the cut index, then it just cuts at the end and essentially.
Gotcha, so we can combine this cut equals 0 with this size is 0. So this is just the same logic. And then if it's greater than size, then it's just one more if statement that we do here. Because if it's greater than size, cutting at size does nothing. So you can just return.
The new list is just the size of 0.
Yeah, exactly. So I think that's a pretty straightforward or trivial change to this existing code. I think what's really important is that you know if you need to access something, be able to intuitively do something like construct this loop to access the tail. Just set the tail to the head while it has a next. Move to the next. As soon as it doesn't have a next, you're at the tail. If you feel like that's intuitive and you can generate that on your own, then great. So we still have a couple things left to do at the end of this. Are there any other issues with any of the logic that I've assumed as I've been putting this together? So we say we have the associated sizes. What's left to do? Return the new list. That basically does it. Does anyone have any questions about this logic or how you could manipulate this logic to be able to answer any related question that might show up on the?
Do we get access to the Java API during
Yes.
this? Oh,
Yeah, you have access to the Java API.
cool. Is it just like downloaded like in the folder or something?
Yeah, I think basically what we do is we turn off the internet except for a few cached pages.
Okay.
So we download the Java API HTML and then basically allow you to, in a browser, go to that site, but it's actually disconnected from the internet and we're using a cached page of the Java. We'll go access.
Sounds good.
What is the tab?
This is just if the cut is 0, then we're saying this list should be null, and we want to return a new list that is this node. So we need to store off this node, because as soon as we set this list to null, then we lose access to it. So it's just a temporary pointer to this node, so that we can return, I guess it's just a node, we need to return a linked list with that node. So this should be. We're not quite done here. If we do this, then we want to link list, new list. New linked list. Link list, new list. Dot head equals temp. New list. Size equals 1, return new list. Forgot to enter current list. And that's tiny handwriting. Feel free to come up and take a look at this. Had to make it fit in there. I know that's not remotely visible. But it just says that now we make a new list. We set the head of the new list to temp, which is stored as the 1. Remember, this is if size is 1 and cut is 0. So it's the only node that's in the linked list. And we want this object to be null. And we want to return just this node, a list that contains this node. So we make the new list. We set the new list's head to this node. We set the size to 1, and then we return that list after setting the head and tail that doesn't exist to null. So this list's head is now null, but this list is null. Because it doesn't have a tail. We cover next. If there aren't any other questions about this or tangentially related things to this. Feel free to come up and take a picture if this is useful.
Sorry, you dummy phone or this one, the sword.
I mean, I already have to know what I'm gonna do with sort. You guys can, for sure.
Yeah, I'll ask about that. Everyone's going to sword. And.
What kind of sword?
Just like.
You don't just do any sort of. It's really-
Yeah, you can choose to do any sword.
9 selections or.
It's the most intuitive by far. And when you're crunched for this, choosing the more intuitive over the more efficient is absolutely always the right way to go. It's harder to mess up what you find to be the most intuitive. So whatever sort is the most intuitive to you, use that. For me, that is selections. Although insertion sort of a close second. Bubble sort of clear. Other questions? Yeah,
This is pretty easy, but you wanna maybe just review like the file, input and writing stuff.
yeah. So they have to be using print stream, right?
For sure.
That's all.
So I am not used to using print stream as my IO.
Have you looked at the file section?
I'm looking at it right now.
Basically, in the instructions, it literally tells you like what to do for everything.
Oh, okay, so it's not that.
I think the biggest thing is just knowing, I guess, what the names of each of them are, so like. Between like the print stream name. Like when it tells you like create scanners or create a print stream. You'll have to use the right name or else it'll all together.
Okay. Oh, yeah, this is about that. And we have the API, so.
Yeah, that will absolutely be helpful. I'm used to using file objects, scanners pointed to files, for reading in files, and I'm used to using think it's file writers. A file writer object will also write to a file in a very similar way to the way that the file object works for reading from files. That's my go-to.
Oh, we have one of those with this scan object. I mean, I don't know if we wanna go over this one, but it should only take 5 minutes. To do.
Yeah, what's the problem?
Let's see, write the code for a step down, close input file. You have to use input file class. So first you check to see if the input file is open. Via the is open field. If it is open, do the following. You close the scanner field. Which they've specified as input file, and they've already declared the input file as a scanner. You set the scanner field to null, you set the file field, which is already defined as file and named to null. There's a custom error message string, you set that to null. Yeah, this is really short. And you set is open to false.
That seems reasonable.
And when the file is not open, you assign a custom error message.
That seems
That's
way
how-
harder than what I use.
Yeah, shoot, this was like 6 lines.
Registrators are super easy though. Dang.
How long usually consider grade level?
It's pretty fast. It should be graded by the end of the week.
Oh, okay, cool.
Do you know where they had it now?
In the what?
Let's
Add nodes with what?
it just says adding and all things.
Yeah, so add an index or at the end of the list.
It's a empty list, the knowledge list, we can try to put that back in the.
Yeah, so. Everyone have what they need from this?
Does it get graded on Canvas, like on the class?
I think
Well,
it's a
that's so-
separate. Forget exactly where you go to look for it.
You might just send us an email or something.
I think it gets posted, if I remember correctly, it gets posted somewhere. All right, so all of the adding that we can do. So I'm gonna assume we have an overloaded add function, kind of add at the end and add. Add an index. And add at the end, you just have to check if the list is empty, because then you have some additional work to do if the list is empty. So let's first. Look at, actually, I'll write these next to each other. Okay, so if we're adding at the end of a list. What interesting cases could we have and come up with? Yeah, we definitely have the, if it's empty, is every other case generically the same?
Yeah.
So let's just basically create the empty list case if. Size. Is 0. Then our add wants to, we want to. I guess this add takes a node, right? And this takes a node and an index. Alright, so if the size is 0, then we want to take this node and append it to the list. How are we gonna do that?
Add and we put that in something that's a 0.
We could call this add. I think it's even easier than that. We just say. That the head to the node was passed in, about the size. Because the head will exist, it's null, because we made this object. In order for this object to exist, the head field was created and set to null, so we can just set the head to the node. I guess we should probably technically return here. Is add Boolean or void? Void, so we can just return. All right, if the size is not 0, what do we do? We don't have a tail. That's annoying. We do basically exactly what we did in the last for finding the tail. You may find that you end up doing this a lot. Whenever you would want there to be a tail field, you're just gonna have the exact same copied and pasted loop that goes and does a linear time find for the tail. I hate this setup, but if it's what you need to do, it's what you need to do. Tail pointer saves you all the time in the world. So we will just say node tail equals head while tail dot next is not null. Tail gets tail dot next. And now tail points to the tail. How do we add this node that has been passed in the end of the list, given that we have the tail now? Yeah. We say tail dot next equals node. And we probably want to make sure this node's next is null. Bump size. Something like that. We don't have to update the tail because the tail is not a field. Which I guess is kind of nice. I would rather update the tail than write a loop to find the tail though. Excellent. What changes when we're adding a node and an index? What error cases or edge cases do we have here?
Which are outside of the size of the list.
Yes, so we're trying to, if index is less than 0 or is greater than size. I guess, yeah, if index is size, we're adding it at the end of the list. So if size is less than 0 or size. Index. Then exception of some kind. I don't know which exception is expected here, but throw some kind of exception. So if we're outside of the bounds, if we get past this, then we know that index is in bounds and there's gonna be some way to add it to the list, which, great. Any other edge cases we need to figure out? Very similar to this, like if the size is already 0, then we actually need to set the head. That's the only case in which we need to set the head. So we need to identify that case. You can just borrow all of this logic. If size is 0, then head is the node, size plus and return. So this entire chunk of code. You just go right here. I don't think anything changes. Yeah. Yeah, so now we know the size is not 0. If the size is not 0, then the head is already set, so we don't need to worry about setting the head. So we need to figure out and iterate to index. So we can do that with just a for loop. Probably set some kind of current first. So this should iterate enough times to get to the index that we want to add it. Should it be less than index, or should it be less than index minus 1? Which one and why? If you didn't know this, how would you figure it out? You could draw out an example of some kind. It doesn't need to be a big example, just on scratch paper, just some kind of very small, all right, we have this, 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 and we want to add an index 1. We're gonna add some node at index 1. So does this index mean add after 1 or add at the index 1? At the index 1. So we want the new node to go here. So if this is cur at the head at index 0, and we say we want to be less than the index, is 0 less than the index? Yes, so we're gonna set cur to cur.next, which we don't want to do. So this index should be index minus 1. An example, just a basic example, as simple as you can make it, will help you to figure out something when you have a question like this. Whenever you do something like this, do not assume. Just draw it out and have the logic tell you what you need to do. All right, this should grab the node before what we want to add. So what are the associated connections that we need to make? So we have some node object that was passed in. We want this node to go there. What connections need to be made and in which order?
When I temporarily stored current stuff next.
Yeah, so currents.next needs to be updated to be the new node. But we need to store this node because we need to set this node's pointer to that node. So I think rather than even temporarily storing it, we can just say this node.next equals cur.next. So now this node that we've made here, we're just going to draw it out. Its next points here, which is good. What's the last change we need to make sure that it's inserted correctly? Yeah, cur.next equals node. So that's gonna point this arrow from here to here. And now we see that we have successfully inserted this node into the list. The list now takes this detour from where it used to be, making sure that it passes through the new node correctly. Yeah.
What if you did it opposite? What if you did cur.next equals node, would that not work?
If you did cur.next equals node, we've lost the ability to access it. How do we access this to be able to set the node.next to the cur.next? So this order is really important. If you do this before this, we've lost access to this. We can't access cur.next anymore because cur.next is now the node. We've cut this off here. So again, drawing this out is very helpful as you figure out what is it that I need? Oh, wait, I don't have access to it anymore. As you realize that, you realize that you need to insert a line here before you lose access to it. So the image really, really helps. I would argue for everything on the 8th. The 8th can probably be done if you absolutely knew what you were doing and you sat down and you just did it. Within an hour, you would be done. You have way longer than that. And the goal is to make sure that it is as correct as possible. So I would be spending the time for every little piece of code that you write, draw something out for it. And that just ensures that to the best of your knowledge, you are doing it correctly. You're going to minimize the number of bugs that are in your code. Don't make assumptions. You just have a few minutes left. Any questions that just take a few minutes? Who in here is not in my 212 class and is taking the 8th? So if anyone would like, that class is offered from 12 to 1 in 220. Cat 220. Feel free to come down there. We're going to be doing more of this studying. If this was useful to you and you'd like another round of it, you're welcome to attend there as well. I will also have office hours in between 1 and 10 if you have any individual questions. I can answer any individual 8-related questions, homework-related questions, class-related questions. Let me know how I can be useful. I want to maximize the chance you do well on the 8th. Anything else I can cover with 2 minutes? It can take longer than 2 minutes. I'm not being asked to do it in 2 minutes. All right, I will keep asking the exact same question in 212, starting at 12. Cat 220 for anyone who wants to join for that.
What room number is your office?
334. Yeah. That's good. See everybody next week. There's more fun stuff.